part 3.
And we're off. And a happy new year. Did you record this one?
I'm recording it now.
Copy that.
Okay, so let's recap. We know that the derivative of position is velocity. We know that the derivative of velocity is acceleration. So, how could we determine position if we knew velocity?
That's the integral.
Integrable.
And what about velocity?
The integral of acceleration.
Excellent. Okay. So, you are going to be asked to find velocity and position functions, except this time we're going to work backwards. Okay, yesterday I gave you position, you found velocity, you found acceleration. Today we're going to work backwards. However, you're going to have to know something about the position function if you're going to go from velocity to position. You're going to have to know something about the velocity if you want to go from acceleration to velocity. They're going to have to give you some sort of initial condition to plug in so you can figure out what that plus C is. Okay? So, let's okay. So we have a velocity of cosine of pi t. And we know that the position is 4 when time is 0. So we know our initial position. Okay? So if we want the position function, we need to integrate the velocity function. So first of all, Allie, what is the antiderivative of cosine? It is negative sign. And what do we have to do with that pi? What did you say? Yes. We have to account for the chain rule, so we have to essentially divide it. Right?
Why is it negative?
I think sine is cosine. What's the cosine and sine?
Yeah, I don't think it's negative.
I don't think it's negative.
So let's do this. What's the derivative of sine? Cosine. So it should be positive. I thought I was going crazy too. It's okay. This is why I like doing this very last, because we get to review everything, right? We get these little mistakes out of the way. So now we need to figure out what our plus C is. We can do that by plugging in 4 and 0. Okay, so our position is 4 when t is 0. What's the sign of 0?
0.
So 1 over pi sine of pi t plus 4 is our position function. Now I want the position function, but we are beginning with acceleration. So we're going to have to do this. Okay, some of you are. Okay, so first we need to get to the velocity function. So let's first focus on velocity. The velocity is going to be the antiderivative of acceleration. Okay, so you know what? You're going to do this for me. You're going to figure out the velocity function for me, and then you're going to stop. When you have it, let me know. I'll tell you the trick.
You said find the velocity.
Go for it. Let's see.
Oh, yeah.
The answer here was 7 plus C is.
Okay.
So you got
So we plug in the
Oh, then you said that one day?
Yeah.
Hold on.
Oh,
Very
wait.
nice. Plus what?
9. 8.
Negative 34, right?
Negative 34.
Yeah, I just remember.
Step over the line. Shoot the freaking. Wait, how did you get on that? It's 800 meters. And your beer is 3. Like you
Oh my God.
Like do you plug in
So
3
you
meters?
plug in 3 for T, and then that should be.
2, and then crack it over here.
I Stop talking.
Okay, we're gonna focus. We're gonna focus. So your antiderivative was t cubed plus t squared plus c. When you plug in 3 for t and 2 for your velocity, you get minus 34. No. So that's our velocity. That's not our final answer, but I'm just going to box it in green just to kind of be organized here. Okay, so now we want the position. And if we want position, we're going to integrate velocity. So this is where it's going to get a little bit. Okay. Aaron, what's the antiderivative here?
1/4 t to the 4 plus 1/3 t cubed minus 34 t plus c.
Okay. Tristan, how do we figure out our plus c?
We have to set it equal to 8. Plug 3 in for t and set it equal to 8.
Okay, so when t is 3, this should equal 8. You're going to want your calculator. You're going to want your calculator is probably going to give you a fraction or decimal. Basically not an integer. Nathan, do you have something?
And it's 2.75.
What?
go for C.
Yeah. Would you? 38.
No.
80.75.
80.75.
Correct.
D.
That's not what you got? No.
80 was after.
One thing I wanted, you don't want to go by this.
You want to.
That would explain.
You want to take 8 minus that.
Okay. That would be
So for our final answer, our position is negative 1/4 t to the 4th plus 1/3 t cubed minus 34t plus 80.7. Is it negative? Ah, it's not. Thank you. Thank you. Okay. The next thing I want to talk about is displacement. We have two different things. We have displacement and we have distance. What does displacement mean?
Actually, something on your 24.
Okay. There is a lot happening at once. Exactly what you said.
Displacement is your actual distance at the end from the point.
Okay.
Point in.
Okay. Anything to add to that?
It doesn't take.
Agree, disagree. Carly's not sure.
I agree. I'm not sure.
Okay. I have a question for you. Can distance be negative?
No. Can't make it.
Okay. Can displacement be negative?
Yes.
Okay. And Aaron, you said yes. If displacement is negative, what would that mean if we're moving left and right?
Well, you're moving left, it's negative. Well, you're moving left if it's positive, actually.
Okay. So let's say that your particle moves, and after 4 seconds, the displacement is negative. What does that mean? Where is your particle?
Oh, I don't even know what displacement is, Miss Lundgren.
That's okay. Oh, I'm asking what you
4
think.
seconds, it's negative.
Uh-huh.
And what does that mean if you're moving left or right?
And I'm saying where is it?
Oh, it's going to be on the left.
Okay. After 4 seconds, if our displacement is positive, where is it? It's on the right. After 4 seconds, our displacement is 0. Where is it? At the origin, okay? So you guys didn't know what displacement was, but we figured it out yourself, okay? Displacement is essentially where did we end up in relationship to the origin, okay? So distance, we're just talking about how far we've gone. Displacement is saying where we are from the origin. So you're going to have a measurement, okay, 4 units, 5 units, 6 units, but it's either going to be to the right or to the left. Okay. Now, I want to go back to this picture. Do you remember this picture? Okay. What is true about this area down here?
It's negative.
It's negative, okay? If we know the velocity function, how do we get to the position function? The antiderivative. And when we evaluate an antiderivative, we are finding what graphically?
Area under the curve.
The area under the curve. So if this is our velocity function, then when we find the area under our curve, we are finding what? Our displacement.
Each individual area is a distance traveled in any direction.
Right. So from A to B,
It's a positive distance.
okay, so after at point B, we are 5 units to the right of our origin. Okay?
Yes.
But then we travel left. What is the integral from A to C? 1. So we'd be 1 to the right of our origin. You see what I'm saying? Okay. So displacement is essentially here. I'll write that over here. Displacement equals the integral of velocity on an interval. We're finding the area under the curve of our velocity, and so it's going to give us our position. Okay, so we are going to find the displacement of our particle when the velocity equation is this on the interval 0 to 3. Okay, so what we're going to do is we're going to take the integral from 0 to 3 of t squared minus 2t dt. Okay. So Allie, antiderivative of t squared minus 2t.
1/3 t cubed minus t squared.
Excellent. We're going to evaluate it from 0 to 3. Oh, it's 0? Okay, Jimmy, what does that mean?
It's at the original position.
Okay. So it is at the origin. That is our displacement. We came back to the origin.
The origin point where it starts, not the actual origin.
That's a good point.
That is true.
Original position.
That's as it being said over here.
It's at the original position because we're just looking at the displacement over the interval. We don't know where it starts. We just know that wherever it started, it came back to that place. Okay? Now, our displacement is 0. But did the particle stand still for 3 seconds? No. It moved, but it just came back.
It's like going in a roundabout.
Okay.
Go around this, come back.
So, how could we figure out the distance that it traveled?
Rick, as you do its parts, we're using its integrals. No,
Okay. That is it. Well, I don't know what you mean, I guess. You don't know what you mean? Okay, Nathan? Antiderivative and plug in 3, but then you still have your plus c.
So what exactly are we trying to find?
Distance.
The distance to travel?
Distance. Okay, let's go back to this picture. Okay?
Oh,
From A to C, our displacement was 1.
You can split it up for A, B, C, so whatever goes positive.
Okay. So here we have negative displacement, right? But we're still traveling. So what Nathan is saying is since we switch from positive area here to negative area here, right? We can essentially for distance, this is going to become a positive 4, right? Our displacement was left 4, but it still traveled 4. We don't care about negative displacement anymore.
So would we take the integral from, in this equation of 0, 1, 1, 2, 2, 3?
Not necessarily.
You have to find where it goes.
Okay, so Okay, so Rebecca said we want the absolute value, but we can't, when we take the absolute value of an integral, we have to consider, what did you say?
Where it goes from positive to negative.
Or vice versa, right? Anytime it switches from positive to negative or negative to positive, we have to have a separate integral for, okay? So let's get to here. So to find the total distance, we're going to integrate the absolute value of velocity. Okay, that was said. Basically, any negative area under the curve is going to become positive. But we have to do work on our end and figure out where it's negative. Okay? Because we don't want it to be negative, we want it to be positive. All right? So this is what I want you to do. Okay? We're going to figure out where's our velocity positive versus where it's negative. Do you need to go back?
Okay. Very good.
Okay. We need to know where we're positive versus where it's negative. Okay, this is important. You should probably write it down, that the distance is the integral of the absolute value. That notation will be important. Okay. So then we're going to break up our integral. Okay, we're going to figure out where is it switching from negative to positive, positive to negative. Any of our areas that we know are going to be negative because it's moving left, we're going to subtract those negative areas. Essentially, we're making them positive. We're just going to throw a negative sign out in front to make them positive. Well, really 11:30 because we have announcements. So you guys are going to have a lot of work time, okay? There's only 2 slides left. Okay. So we're going to go back to the example that we did. What was our displacement?
0.
0. Obviously not our distance traveled. Okay? So I want to know the distance traveled. We need to first figure out where this particle is moving right versus where it's moving left. And how do we determine that? No. Right.
So it equal to 0 and find the critical points and uses that chart.
Okay, what is it? Okay, what part do you agree, what part do you don't agree with what you just said? We said the velocity function equal to 0 is what Zach says. Brady says he agrees.
Well, Brady agrees and I agree.
Rebecca, what do you think? Lost me. You were thinking derivative because we were taking the derivative position, right? Okay. So what we need to keep in mind is when we're talking about left and right, we want to know where the velocity is 0 because that's where we would, like if I'm moving, this is your left, if I'm moving left and then I move right, I have to stop and switch directions. Okay, so when the velocity is 0, that's when we could be switching directions. So, where is our velocity 0? Okay, between 0 and 2, this velocity would be? Between 2 and 3 is really, we have positive. Okay, so when we are finding the distance, we are essentially taking the integral from 0 to 3 of the absolute value of our velocity. Okay? Now, since we have negative velocity from 0 to 2, we know that we're going to get negative area, correct? So, when we take the integral from 0 to 2 of t squared minus 2t, that's going to give us a negative value, so we're going to throw a negative in front of it to make it positive. And then we're going to tack on the integral from 2 to 3, and we're going to leave that as is because we have positive velocity. We're going to get positive area.
Now what if they're both, just somehow they're both negative? Do we just do one big one then?
And it couldn't have been 0 displacement.
But it's a valid question. You still...
You could just take the absolute value of the answer then.
Yes. If they go from negative to negative, then you can take one integral. It's when it switches that you have to break it up. Okay?
So even if a displacement is polar, you can still have a gradient distance.
Correct. Because I could just move back and forth and then end up over here, but I traveled a lot.
Even the turbo right there.
Okay, so can you please follow this? How about pods 1 and 2 evaluate the first integral, pods 4 and 5 integrate the second.
What about pod 7?
Pod 7, they're working on their, I guess, other two students. Yeah.
Oh, like,
So they're understanding everything that I'm saying. Got it.
Cherish the outdoor 2 days.
yeah.
Okay, so
I got my 2 last night.
no, I said strong.
That's not a great song. I got the answer.
Great.
Oh, look at you.
Yeah, I got it. Exactly. I'm gonna fail these 2 worksheets. Is it right? Wait, I take my time. Have you? No, it's just a lot to take, like, you know.
No, yeah.
It's a lot.
I know. But that's why you took good notes.
Oh, I got I think this is my 3rd page today. One over 2 last 2 years.
Still 0.
Okay, let's see. Someone from pod 1. What's this first integral? 4/3? Someone from pod 5?
4/3.
8/3 is our answer. Okay, in light of you guys being just kind of mentally exhausted, we're going to stop here. And I'm going to give you your second worksheet, and you're going to get time to just let it sink in, work through some problems. I'm losing you. I don't blame you for